Hello everyone, myself Harish representing EGS India. I welcome you all for the webinar on the topic Predicting Products Mean Time Between Failures. Every product in the market tends to fail over a period of time. The organization gives a warranty period approximately for 1 year or 2 years for their components. But this period is given on the basis of experience or by means of some other activities. Taking all these things into account, it is really hard to predict the failures occurring in the meantime and also the parts which need to be replaced after the time period. So here I introduce the tool SolidWorks Simulation. SolidWorks Simulation is a virtual test on the product designs in real-time conditions before the manufacturing stage. It is a process of validation where the designers have the scope of innovating new concepts through designs. With the help of this tool, the designer has the confidence in delivering the final product design, ensuring the product performance by improving the quality and safety. Since you all know SolidWorks is a user-friendly tool, simulation is also of the same kind. With the help of 5 steps, you can perform any complex problems related to design. FEA involves 3 stages: pre-processing, solving, and post-processing. So SolidWorks simulation bridges the gap between the designers and FEA analysts. The designers will have a visual feedback taking place on their designs. Here, I have an example of a steering bracket assembly. As a designer, I need to design based on the strength by keeping the stresses below along the model. Then, I need to design for life by predicting the durability of my product. In case, if you come up with an issue before the warranty period, then there will be an approach to you by the service department. So, while designing itself, a designer can overcome all these problems. Then, we need to perform a frequency check in order to maintain the resonance. The first step is to perform a static analysis on the assembly. Moving into the SolidWorks interface. This assembly is designed in SolidWorks and now I use simulation to validate my assembly. Adding in the simulation for my further process. Dropping down the static analysis to find the stress, strain, and displacement. The first step is to assign the material for all the parts. SolidWorks has a vast material database, and for simulation, the material library consists of the SN curves which is required for the fatigue analysis. Now, I apply the aluminum 6061 alloy to provide the mechanical properties for my design. If you have more components in your assembly based on the boundary conditions, you can provide the component contacts. The next step is to provide the boundary conditions. Based on the real-time conditions, I provide a hinge support to all the 3 holes. And I provide a roller support to the backside face. I apply a gravity to the assembly by taking the top plane as my reference. And I apply a force on the rod ball of 6000 Newton by taking the selected face as my reference. The next step in the process is meshing, where I will convert the solid geometry into FEA model. For more finer results, you have an option of sliding the scale. Once the meshing is done, the meshed model will have the elements and the nodes. The final step is to run the analysis. Once it is done, I have my stress result. The result gets displayed by means of colors and the analytical values. The material yield value is displayed on the result scale. The maximum stress value is around 120 megapascal, which is more than the yield value. The next plot is the displacement plot, which gives the deformation taking place across my model. For each and every analysis, there is an option of generating the report automatically in the Word format, which is a customizable one. From the static analysis, I can conclude that the design is not safe under the operating conditions. I use fatigue analysis to find the life and damage taking place for my design by specifying the number of cycles. By specifying the number of cycles as 1 lakh to find the optimized design for the steering bracket. Moving into the interface again and selecting the fatigue analysis from the new study. We specify the loading conditions by directly linking the static study into the fatigue study. Based on the loading type, the user can choose the peak and rally. Specifying the number of cycles to be 1 lakh. As I told before, the SN curve is inbuilt in the material database. If any changes also, the user can write all the values in an Excel sheet and import it for the further validation. By running the analysis, I have the results for the life and damage. The life plot clearly suggests me that the design is safe till 34,000 cycles. After that, I need to concentrate on the stress formation areas for my design. The next step in my process is to perform a frequency check so as to avoid unwanted vibrations on the steering column. Frequency analysis is used to find the change in mode shapes of your design under vibration. Moving into the interface again and selecting the frequency from the new study. The simulation tree resembles the static study. The user has an option to simply drag and drop the necessary details from one study to other. Now I apply the material from all the parts by copying from the static study. The same I do with the fixtures. Using the default mesh, I continue the meshing process. Once I run the study, I have the resultant mode shapes for my design. By taking the resonant frequency values for the associated mode shapes, and with all these values I can match it with the natural frequency. The design insight plot is used to find the most loaded areas along the design. Now I use it to remove the material for my design to make it an optimized one. By simply linking the dimensional parameters from the design, I have an optimized design by reducing the weight and by reducing the thickness of the material as well as maintaining the stresses below 150 megapascal. Approximately, the weight has been reduced by 10% and ensuring the safety of the design. This slide gives me a clear conclusion stating that the design will be more safe for 1 lakh cycles with a thickness of 3.875 mm. So, by using simulation, I can not only predict the life cycle of my product but also produce optimized design for the manufacturing department, and it also provides the designer to make an immediate actions for the product which he designs. Thank you.